Okay, in previous video we explained the absolute and relative gravity measurements in Nepal. This was the first part of the question, and here is the second part of the question, which is how this measurement can be used in determination of gravimetric geoid of the country. And this video will be about this. There are various steps to determine a gravimetric geoid. The first one is a gravity measurement. You carry out either absolute gravity measurement or relative gravity measurement in the field. Actually, both absolute gravity measurement is done first, followed by relative gravity measurement for the purpose of producing a gravity dataset to determine the gravimetric geoid. So after you perform the field works, the second step is pre-processing of those gravity data. The third step is a gravity reduction is done from surface to sea level. Fourth is computation of gravity anomaly. And the final step is geoid height computation using a gravity anomaly obtained in previous step. At last, I will discuss the gravity dataset available till now in Nepal and gravimetric geoid developed from those available gravity dataset. So we already said the first step is we must have gravity dataset. For that we need to perform a gravity measurement at the site where the gravity information is needed. And we already said at first absolute gravity measurement is formed, then followed by relative gravity measurement. Here we will discuss about absolute gravity measurement. The main purpose of absolute gravity measurement is to establish a gravity base station. Gravity base stations can be established either by absolute gravity measurement or by relative gravity measurement. The output of absolute gravity measurement is absolute gravity value, and such station is called absolute gravity station, and such station serve as gravity base station. Relative gravity measurement can also be used to establish a gravity base station. The output of relative gravity measurement is a relative gravity value. Such gravity value is converted to an absolute gravity value, and such station act as an absolute gravity station and serve as a gravity base station for further gravity measurement. While using relative gravity measurement, but to establish a gravity base station, such relative gravity survey should be carried out in a very precise and rigorous manner. For example, multiple gravimeters can be used and multiple observations should be made so that the final obtained absolute gravity value from relative gravity measurement would be precise and accurate. In case of Nepal, there was a gravity network established in 1981-84. Both gravity base station and detailed gravity station were established during that period, and it was by relative gravity survey. In 1991, in Nagarkot Geodesy Observatory, absolute gravity survey was carried out. The Gila absolute gravimeter was used to determine the absolute gravity survey. Till now, it is the only absolute gravity survey that have been conducted in Nepal. Later in 1996, UNESCO carried out a relative gravity survey to establish 9 gravity base stations. Now let's talk about relative gravity measurement. First, we establish gravity base station, and there are points to be gravity surveyed. So gravity stations and points to be surveyed forms a gravity network. We always start our gravity survey from a base station. Then we follow a ladder sequence or a profile method to survey each gravity station, and we always come back to a starting station and close the observation at each loop, and we try to constrain ourselves within 8 hours to complete a gravity survey for a single loop. After we collected gravity data in field, the next step is pre-processing. In pre-processing, raw gravity values collected at the site is converted to our absolute gravity values. So in the process, we apply drift correction, we apply tidal correction, we perform a least square adjustment to obtain final absolute gravity values. After we find absolute gravity value at each gravity station, the next step is of gravity reduction. In gravity reduction, gravity value at station height at the topography is reduced to corresponding point at the sea level. We apply a free air reduction, and the result of the gravity reduction or free air reduction is the measured gravity value at station height is converted to a gravity value at the sea level, and that gravity value is termed as an observed gravity value. Next step is computation of gravity anomaly. First, we compute a theoretical gravity value gamma at the position of that gravity station based on GRS 80 level ellipsoid. And we already have an observed gravity value G at the sea level, which was obtained after free air reduction, and a gravity anomaly which we call free air gravity anomaly delta G FAA. FAA stands for free air anomaly, is obtained by subtracting theoretical gravity value gamma from observed gravity value G. The next step is geoid height computation. Stokes formula in Geodesy takes the gravity anomaly as an input and output the geoid height n. So this is how geoidal height is computed from gravity measurements. So in context of Nepal, we have a urban gravity data set developed and stored in a free air anomaly form. We also conduct a surface gravity survey and stored such dataset in also Fourier anomaly form. So these are the gravity anomaly data, and we use that gravity anomaly data to compute the geoid art. In that way, we have developed Geoid 2011 in past, and recently we have developed Geoid 2020. So okay, in this way, uh, absolute gravity measurement combined with relative gravity measurements are used to finally develop the geoid model.